Hi, this is Mr. Devereaux, and I want to show you how to do some of that work from yesterday because I saw some mistakes and I had some questions about it. So let's look at the first one. This is page 338. Number one, the function of a is equal to 0.2 v squared models the acceleration of some ride. The a is acceleration towards the center of the ride in meters per second every second, and v is the velocity in meters per second. Graph this function. Use the graph to estimate the velocity of the ride at the acceleration of 1 meter per second every second. All right, a lot going on here, but all we really have to worry about is a is equal to 0.2 v squared. It's a function. Before I graph anything out, I want to set up a table. So if I have a is equal to 0.2 v squared, okay, let's set up a table. I have velocity. My function is going to be 0.2 v squared, and then acceleration. Since I set this up like this, I can now label. I'm going to go back and I'm going to label my graph, because that's one of the first things that we have to do. I've got to find out what is my x and what is my y. Because I've got a function like this, and here's my input and here's my output, that means that this is the velocity, is my input. Velocity, VL, where is it over here? VELOCITY. I am your math teacher, not your spelling teacher, apparently, for good reason. And then acceleration, ACCELERATION. Hooray. So velocity, acceleration, input, output. Let's look at this. So if my velocity is 0, I have 0.2 times 0 squared. This equation, this expression right here, means that I've got 0.2 times velocity squared. It's not 0.2 times velocity and all of it is squared. It is just the velocity is squared. And it will make a difference very soon. Not right now. But right now, that means I've got velocity squared. 0 squared is 0 times 0.2. It is 0. That one's pretty easy. Okay? 1. So when my velocity is 1, I have 0.2 times 1 squared. 1 squared, 1 times 1 is 1, times 0.2 is 0.2. Okay? What happens when my velocity is 2? I have 0.2 times 2 squared. What is 2 times 2? That is 4. 0.2 times 4 is 0.8. That's my acceleration. Well, let's go ahead and continue this one more time. 3, 0.2 times 3 squared. 3 squared is 9. 0.2 times 9 will be 1.8. Okay, I'm going to look back at this now. I can graph these. So 0 is 0. That's in the origin. 1 is 0.2. Gotcha. 2 is 0.8, which is right here. And then 3 is 1.8, which is all the way at the tippy top. There it is. So my velocity is 3. My acceleration is 1.8. And this is going to be a curved line. that. There we go. Something like that. And then it asks, use the graph. It's saying use the graph to estimate the velocity of the ride when it is at 1 second. When it's 1 meter per second. So I need it, this is where I'm looking at right here. So where is this? Now, I've talked about this before in class. That's an ish, isn't it? So where is this? Where is that? That is, I'm estimating, right? If I'm estimating, I don't have to be exact. So if I'm estimating on that, you know, it looks like it's less than 2.5 to me. So you say 2.4, 2.3, 2.2, yeah, sure. 2.1, maybe, depending on how you do your graph. So I'm gonna estimate that it's about on my graph here, it's about 2.3. It's about 2.3 meters per second. So that's how we do number 1. I want to look at number 2 because I think that this is where I've seen a lot of mistakes. So I have y is equal to 3x squared. Y is equal to 3x squared. Graph the solution. All right. Before I graph, I need to make a table. So, and I think if you had a mistake on this, you probably had the same mistake. I think everybody did. Y is equal to 3x squared. Now I have to find out, I've got x as my input, I've got 3x squared as my output, and then 3x squared is my function, and then y is my output. Okay, I'm gonna set up a graph. What happens when my input is 0? Now, I think where everybody was making a mistake is in this equation. So it'd be 3 times x squared. Should kind of look like this. I do what's in this parentheses. It is 3 times x squared. It is not, I'll do this over here, it is not 3x and that is squared. That is not what we're doing, okay? So I think this is where a lot of people made a mistake, is they approached it like this, when in reality it is 3 times x squared. Hopefully this clarifies. All right, so 3 times 0, because x squared is 0, is 0. 1, 3 times 1 squared is 1. 3 times 1 is 3. 2, 3 times, what is 2 squared? 2 times 2 is 4. 3 times 4 is 12. Okay? I'm not done, because when we have a quadratic function, I need to get the negative values as well. So what happens if I have -1? So -1 times -1 is actually a +1. So this is +3. And then what about a -2? -2 times -2 is a +4. And that is a +12. Well, I have enough information now where I can graph. Because if I look at my graph, I didn't need to go too much more than that because there's not any room. So 0 is at the origin. 1 is 3, so if that's 2, that's 1, and then here is 2, and be here, right in the middle of that one. 2 is 12. Three, well, I don't even have 3 on here, but that would be 9 times 3 would be 27. It would be off the charts. That's how far up it would be. Okay, I don't even have it. Whoa, that's way up here. Okay. Now, the negative part of this, because it's a quadratic function, you have to get the negative input. So -1 is a positive 3, and a -2 is a positive 12. Gosh, I gotta tell you, I don't like the graph that they give you. This isn't very helpful the way that they set this up. They're not really doing you any favors the way they set this graph up. So if you did your graph at 3 times x squared, just remember that it is going to be the x is squared and then you multiply it by the coefficient. Your variable is squared and then you multiply. That's what this one would be. This would be the same thing. So now I'm multiplying it by -5x. The way this one is going to look is, well, look at how they're also setting this graph up for you. The way that this one is going to work, it's going to be a downward facing. And I can already tell if I had 0, 0 would be 0, and then 1 would be -5. Be here and here. And then 2 would be, well, that would be at a -10, wouldn't it? Actually, no, it wouldn't, because it would be 4, so it'd be 20. Yikes. It'd be -20. It'd be way down here. So again, they're not really doing you any favors the way that they set this up. The reason why this would be 40, because I have -5 times, what is 2 squared? 2 times 2 is 4, so -5 times 4 is -20. So this would be way down here. So anyways, the real thing that you need to look out for, though, is it is not 3x squared. It is not that. It is 3 times x squared.